So I decided to talk about uniting Yang and Kubernetes, right? Because I was inspired. There was a few talks which I was very interested about. It's like extending or using Kubernetes for like network automation and stuff like that. So what I will there's a clicker, right? Yeah. So what I will talk about is actually So I've been working on an open source project that actually extends Kubernetes to talk to Yang-based systems, right? So I don't know everybody who is not familiar with Yang. Anyone not? Okay, awesome. Anyone not familiar with Kubernetes? Oh, awesome. So what we are basically talking about is actually to bring those two together, right? And for those who are aware, so Kubernetes by default is using OpenAPI as a schema or as the data modeling language. And then in IETF, we have, so we defined Yang as the data modeling, right? So, but what you see is that Yang is way more extensive, so there's way more features compared to OpenAPI. And then the question is, okay, how do we bring them together, right? Because what we see is that there is quite a number of devices. I mean, if you look to network devices, but also optics, IP, even there is people who are using the project to talk to 5G systems. So it's actually built to be vendor agnostic and to work with any Yang-based implementation, right? So now before I go into the details, I want to put a little bit of context, right? Because we saw, I think there was a number of presentations during the course of this week that talked about automation-based approaches, right? So, and typically it's about abstractions, and we have sources of truths and stuff like that. Where this project starts is when the automation defined a device-specific configuration, and then I'm taking that configuration that is vendor-specific and device-specific, and we apply that to the system using Netconf or gNMI, right? So that's what the scope is about. And then when we use Kubernetes, so we have two options. So we either apply that config to the Kubernetes API server, or secondly, you can actually store it in Git and then use one of the GitOps tools like Argo or Flux, and then use that to actually apply that to the system. Make sense? So that's the scope. So I have also ideas on how to do the full automation stack, leveraging Kubernetes, but that's not what I'm going to talk about here, okay? Now, so SDC is the name of the project, and there's a link there where you can actually, so there's full documentation on how it works, so you can actually try it yourself. And I hope I inspire you to have people try it out as we go along, right? But so it's open source, it uses the declarative approach, it's multi-vendor, right? And it uses, as I said, gNMI and Netconf as the protocol to actually interact with the devices, right? It does all the validations using Yang, according to the Yang schema, right? And that has introduced some challenges, by the way, so I'll talk a little bit about that. I don't have the time, but if you look to the project, you see on the right-hand side the components. So we try to build it in a way that you can either deploy it small, right? So you can actually run it on your laptop, but we also want to scale out. So all of these components are a set of microservices that actually can scale to very large systems, right? So we wanted to build it in such a way that we enable people to play with it. And we have customers right now that are using it that are very small, but there is also people that are using it with very large systems. So if you look to implementation, so on the northbound side, we have the Kubernetes API server. So we extended it to basically talk to Yang-based systems. So we have a config server that takes that configuration, right? And then sends it to, so there is data server, schema server, and cache that actually talk with gRPC-based interfaces, and we can scale all of these components independent along the way, depending on how many resources that you need, right? And so if you look to the components, we need a schema server, so we store the Yang schemas in there, right? We have the data server, which is actually doing all what I call the Yang magic, And then we have a cache, right? I don't know anyone who knows why we need a cache in the system. So I think we like declarative systems, right? Because you only say, this is what I want, and then what actually happens underneath, it actually checks what is the real configuration, what is the delta, and then you apply the delta, or you can also do a replace, right, to the full device, okay? Now, if you do that, so when we started with this project, we didn't have a cache and all these intermediary layers. The challenge is that you do a lot of, so I say a declarative system is read heavy. What it means is that you fetch the data from the device, right? And then you apply the diff, and based on that, you actually then compute the delta, and then you do the operation. So what we see, and that is, I think, in general, the challenge in declarative systems is that if you don't optimize it or have this intermediary layer, you actually kill the box, right? Because you actually go and fetch the data, and then for every operation, you actually do that computation, so you interact with the device. So if you look actually SDC as a project, the way I sometimes explain, we are trying to pretend to be the box. So we are trying to pretend to be the device that we are managing, that we are applying the configuration to. So that's in essence what SDC as a project is trying to accomplish, right? Now, I have to go quick, right? But so Kubernetes is famous for extensibility. So here you see, so it's a rather complicated slide, right? But in order to do that operation, we need to understand to which device we talk to, what is the schema that it has, which version does it has, and so on and so forth. So there is a discovery component inside. And so once the discovery is complete, so there's various options, so I'm not going to talk about that. We actually create a target CR into the system, and that target CR is basically a representation on how we talk to the device. And given that we want to support multiple vendors, so some support, so don't even support the candidate configuration, right? So we have all kinds of knobs to actually make sure that we have the tools to actually be able to talk to that device based on the features and the parameters it has, right? So once we discover what you get, you can basically get a running config, right? So you actually can use it for backups. What we also do is when you discover it, so like unmanaged config, and we are going to change the name to deviations, like you could say that the system that we build is kind of an intent-based system, right? So what you see is that if you don't have any intents, everything is deviations, right? So unmanaged config is kind of representing all the deviations that you have because you don't have an intent, right? So everything is actually in deviation. But it's okay, and we allow that to be used, and then what you see is that you can gradually move your system into what I call an intent-based system. Now, besides that, you can apply configuration. If you see here, it's a very simple example of a config, right? So you basically say to which device you apply it, and then we compute all the deltas and stuff like that. And there's two ways to use the system. So some people, they compute the full device configuration, right? Which is what you see on the left-hand side. There is other people that give us config snippets, right? So we also have an ability to actually merge each of these configurations on behalf of the automation system that sits above, right? And so one of the key things or features that is there, and you will see in a bit because I'm running out of time, is what we call config blame, right? So we can actually see on every parameter that you have on a config where it came from, right? So you can actually track which intent was responsible for which parameter that you have on the device. So it's actually rather extensive. I'm going to skip this. Interesting operations are dry run. So you can actually test it. We do the full computation, but we don't interact with the device to see whether that configuration applies to the Yang schema and the device would accept it, right? There is also all the drift detection, right? So if you go on the box and change it, we actually see it, and then we can either accept the deviation or auto-remediate and reapply the intent and stuff like that. There's config blame you see on the right-hand side. And then we are working on what I call network-wide transactions that you actually, that we actually can apply this not on a single device, but actually network-wide, right? And last but not least, it's not only config, we also enabled the ability to get state from the device using gNMI, and as such export the data into Prometheus, for example. So with that, I hope I inspired a number of people. So here is some more references to talks and people who are actually using it in production. Right? So with that, I would like to thank you.